Okay, so today we're going deep on something might seem a little niche at first glance.
Okay.
We're talking about the standards for holes and slots in American steel construction.
Yeah. Right.
I was checking out this blog post from draftsperson.net that you sent over,
Yeah.
and really kind of opened my eyes to like the level of detail and thought that goes into, putting buildings and bridges together.
Right.
So I think our mission today is to like try to understand why you see different types of holes in steel. Why they're not all just round.
Yeah.
And then dig into the world of anchor bolts, which is way more complicated than I thought it would be.
Oh, yeah.
Those big bolts that connect steel structures to concrete foundations.
Uh-huh.
So yeah, these little details, they actually have huge implications for how structures go together and how they stay together.
Yeah, absolutely. I mean, when you look at a finished steel building or bridge, right?
Yeah.
The connections are really what are holding everything together.
Right.
And at the heart of every connection are these holes, Yeah.
And this blog post, it really highlights that there's a very specific reason why each one of those holes is designed the way it is.
Okay, so let's start with the most basic type, the standard hole.
Okay.
The blog post says these are usually 1/16 of an inch larger than the bolt diameter.
Right.
Now, that seems like a tiny amount of space.
Yeah.
Why is there that little bit of extra room around the bolt?
Well, 1/16 of an inch, it's actually really important for making construction work.
Okay.
You got to imagine trying to get like these huge steel beams lined up perfectly.
Yeah.
Not just in a shop, but out on a construction site.
Right. Could be windy.
Yeah, exactly.
Yeah.
That tiny bit of extra space makes it so much easier to get the bolts in.
Right.
Without having to like force anything.
Yeah.
Or, put extra stress on the steel.
Right. So it's a practicality.
Yeah. It's a really clever way to make things work better on site.
And the blog post mentions that standard holes are like the default choice for high strength bolted connections.
Yep.
Unless an engineer says otherwise. Uh-huh.
Which suggests that they're pretty strong and reliable in most cases, right?
Yeah, exactly. For most steel connections, standard holes are going to give you the strength you need while still being pretty easy to put together.
Right.
And what's cool is that even with that little bit of clearance, the connection can still do its job structurally.
So it can still hold all that weight and everything?
Yeah.
That's interesting. The blog post actually even mentions you can use finger shims in slip-critical connections with standard holes.
Yeah.
Those little metal pieces that fill in gaps, up to 1/4 inch of them without messing with the sheer strength.
Yeah, it's pretty remarkable. You can make those small adjustments, and the connection's still going to be able to resist those forces.
Okay, so even with a little tweaking, the strength is still there.
Yeah.
That's good to know.
Yeah.
Now things get more complex when we start talking about oversized and slotted holes.
Right.
The blog post is very clear that you got to have an engineer sign off on these.
Yeah.
So why are these types of holes treated with more caution?
Well, with oversized and slotted holes, you're introducing more potential for movement in the connection.
Yeah.
Now, sometimes you want that flexibility.
Yeah.
But it also changes how the load gets transferred between the steel members.
Okay.
So these holes aren't the default because they can reduce the contact area between the bolt and the steel. And they can also make the joint a little bit less stiff.
Okay.
So you got to be careful with them.
So it's a trade-off, right?
Yeah.
You're getting that movement, but you might be sacrificing some strength or stiffness.
Right.
So let's break it down a little more. First, oversized holes.
Okay.
The blog post says they could be used in connections where the slip resistance is higher than the load, but not for bearing-type connection.
Right.
So what's the difference between those two?
So think of it like this. Some connections are designed to stop movement by using friction.
Okay.
The steel surfaces are clamped together so tightly by the bolts that they basically stick together.
Right.
That's what we call slip critical.
Okay.
It's all about that stickiness.
Other connections, bearing type, they rely on the bolts themselves, pressing against the sides of the holes to carry the load.
Okay, so the bolt is actually taking the force.
Exactly.
Okay.
Now, with an oversized hole, the bolt can move a little bit before it makes contact with the steel.
Uh-huh.
So if the friction is strong enough to handle the load, that little bit of movement is okay.
Okay.
But in a bearing-type connection, an oversized hole could mean too much movement, and that can put too much stress on the bolt and the hole.
Right, because it's like a smaller area of contact.
Exactly.
Yeah.
And the blog post also makes a point of saying that you have to use hardened washers with oversized holes.
On the outer layer.
Yeah, on the outer layer.
Why is that?
Well, that hardened washer spreads out the clamping force over a bigger area.
Okay.
So the bolt head or nut doesn't dig into the steel around the hole.
So it's like protecting the steel?
Yeah, there's like a little shield.
Okay, that makes sense.
Okay.
Okay, so next up we got short slotted holes.
And here, the rules seem to depend on which way the force is going relative to the slot.
Yeah, that's one of the interesting things about slotted holes.
Okay.
How the load direction affects things.
Okay.
So if you've got a connection that's designed based on how much stress the bolts can handle, like the bolt itself is doing the heavy lifting,
Okay.
you can use short slotted holes in any layer.
Okay.
But the force should be pretty much perpendicular to the slot.
Okay, at a right angle.
Yeah, about 80 to 100 degrees.
Okay.
The idea is the slot allows movement in one direction.
Right.
But the bolt can still hold strong against the force that's trying to push across the slot.
So it's like controlled movement.
Exactly.
It can move this way, but not this way.
Right.
Okay.
Now, if the connection is mainly relying on friction to hold things together,
Uh-huh.
then you can use short slotted holes no matter which way the load is going.
Oh, okay. So it's more flexible.
Yeah.
But either way, you got to use washers on the outer layer
Right.
and hardened washers if
Yeah.
you're using high-strength bolts.
Yep. That's important.
Okay, so it seems like it's all about managing how the connection can move.
Yeah.
And making sure there's enough contact between the bolt and the steel, depending on whether the connection is using the bolt's strength or friction to hold everything together.
That's a good way to put it.
And then we have the long slotted holes,
Right.
which the blog post says are even more limited in how you can use them.
Yeah, they are.
Why is that?
Well, a long slot gives you a lot more movement in one direction, so
Okay.
you got to be extra careful. They're
Uh-huh.
usually only allowed in one of the connected parts at each contact surface.
Okay.
If the design is based on the bolt strength,
Mm-hmm.
and again, the load should be mostly perpendicular to the slot.
So same rule as the short slot.
Yeah, pretty much.
Okay.
And that's because a long slot makes things a lot more flexible.
Right.
Now, just like with the short slots, if the connection is relying on friction to resist the force,
Yeah.
and that friction is strong enough, then you can use long slots in one part without worrying too much about the load direction.
Okay, so friction gives you more flexibility.
Exactly.
But the hardware for long slots in the outer layers, that gets pretty specific.
Yeah, it does.
What's the deal with that?
Well, because of that long shape, you got to make sure the bolt head or nut doesn't just pull straight through the slot.
Right, they need something to grab onto.
Exactly.
Got it.
So the standards say you got to use plate washers or continuous bars.
With standard-sized holes.
Yeah. They need to completely cover the slot after the bolt is installed.
So it's like a backup system.
Yeah, basically.
Okay.
And for high-strength bolts, those plate washers or bars got to be at least 5/16 of an inch thick.
Okay, that's pretty hefty.
Yeah,
And made from structural grade steel.
right. But not hardened steel.
Oh, okay. So regular steel.
Right.
And if you need a hardened washer too, it goes on top of the plate washer or bar.
Exactly.
So it's like layers of protection.
Yeah, it's all about making sure that connection is secure.
Even with that big slot.
Right.
Okay, so it's becoming pretty clear that these different hole types aren't just random choices.
No, not at all.
They each have a specific purpose,
Uh-huh.
and there are rules to make sure the connection stays strong.
Right.
Now, the blog post has this really helpful table that shows the dimensions for all these hole types.
Yeah, it's a great reference.
It's based on the bolt diameter.
Uh-huh.
So it starts with half-inch bolts and goes up to bolts that are bigger than 1 1/8 inches.
Right.
And it tells you the size for standard oversized,
Yeah.
and then the width and length for both short and long slots.
It's really handy to see it all laid out like that.
Yeah, I mean, for example, for a 3/4 inch bolt,
Yeah.
the standard hole is 13/16.
Okay.
Oversized is 15/16.
Uh-huh.
Short slot is 13/16 by 1 inch.
Right.
And long slot is 13/16 by 1 7/8 inches.
That's a pretty big difference.
Yeah, it's way longer.
Yeah, you can really see how much bigger the oversized and slotted holes are.
Yeah. Yeah, compared to the standard one,
Uh-huh.
and how much more they let things move around.
Exactly.
Okay, so now let's switch gears and talk about anchor bolt holes,
Right?
where the steel connects to the concrete.
Yeah.
Now, the blog post points out right away that the rules are different here
Right.
than for steel-to-steel connections.
Uh-huh.
So why is that? Why are things different when you're dealing with concrete?
Well, the main reason is that you can't be as precise when you're working with concrete.
Okay.
In a shop, you can drill holes in steel with really tight tolerances.
Right. Very accurately.
Yeah, but when you're putting anchor bolts in concrete, it's much harder to get them in exactly the right spot.
So there's more room for error.
Right. Okay. Things like the concrete mix the formwork.
Yeah.
Even the weather can affect how accurately those bolts get placed.
Oh, wow. So it's a lot less controlled.
It is.
Okay.
And actually, the blog post mentions that the AISC, the American Institute of Steel Construction, they noticed a trend of the quality of foundation work getting worse back in the early 1990s.
Really?
Yeah, they said it was worsening, which is a pretty strong statement.
Yeah, it sounds like they were concerned.
Yeah, and because of that, they decided to allow bigger holes in steel base plates to account for these less than perfect anchor bolt placements.
So they knew that things weren't as accurate.
Right.
And they needed to give people some wiggle room.
Exactly.
Right.
This guidance is in their Steel Design Guide Series 1.
Okay.
Now, it's important to remember those are the maximum allowed hole sizes.
Okay.
You can use smaller holes if you can get the anchor bolts in more accurately.
Right, if you're confident in your concrete work.
Yeah, but the blog post also says that you usually need plate washers with these bigger holes.
Why is that?
Because standard washers, the ASTM F436 ones, they can actually be bigger than the oversized hole.
Oh, wow.
And they might fall in.
Even just from the weight of the steel.
Yeah, it's kind of crazy to think about.
So the plate washer acts like a bigger platform.
Exactly.
To spread out the load.
All right.
Okay, so these larger holes in the base plate, they're basically giving you a safety net.
Yeah, that's a good way to put it.
In case the anchor bolts aren't perfectly placed.
Right.
And the blog post says this is especially important for base plates that are mostly dealing with compression.
Where the main force is pushing down.
Right, like the weight of the building.
Exactly.
So in those cases, the anchor bolts are mainly there to hold the base plate in place while you're putting the building up.
Right.
And to resist any uplift sources. But they're not as critical for carrying that main downward load.
Right, so a little extra space in the holes doesn't really affect how the compression gets transferred.
Okay, so it's not as big a deal if they're a little off.
Right.
Okay. And the blog post lists the AISC's recommended oversized hole sizes for anchor bolts.
Yeah.
And they're huge.
They are.
Like for a 3/4-inch anchor bolt.
Yeah.
They recommend a hole that's 1 5/16 inches.
Wow, that's a ½ inch of extra space.
Yeah, and it gets even bigger for larger bolts.
Right.
Like a 2.5-inch anchor bolt needs a hole that's 3 3/4 inches.
Yeah, they're really taking into account how much things can move around in the concrete.
Yeah, it makes you realize how much harder it is to be accurate with concrete.
It really does.
Than with steel.
And
it sounds like even those big holes might not always be enough.
Right.
The blog post says the AISC even suggests adding another 1/4 inch to those oversized diameters.
Just in case.
And always using heavy plate washers.
Yeah, they're not messing around.
They even have an example from the AISC Structural Steel Educational Council that says you can usually deal with misplacements up to a ½ inch with those bigger base plate holes.
Okay.
But if the anchor bolt is off by more than that, you got to fix the foundation.
You got to do some serious work.
Yeah, so that ½ inch number, it really shows you how much things can go wrong out in the field.
It does.
And why you need those big holes and heavy washers.
Yeah. They're like your insurance policy.
Yeah, okay. And then the blog post brings in the perspective of the American Society of Concrete Contractors.
The ASCC.
And they have their own recommendations for how accurate anchor bolt placement should be.
Yeah, it's interesting to see what the concrete guys think is achievable.
Okay.
They have different tolerances depending on the bolt size.
Okay.
So for smaller bolts like 3/4 or 7/8 of an inch, they say plus or minus a 1/4 inch is okay.
Okay.
But for bigger bolts like 1 3/4, 2 or 2.5 inches, they allow up to plus or minus a ½ inch.
So the bigger the bolt, the more leeway they give you.
Right.
Okay.
Which makes sense when you think about how hard it is to get those big bolts in exactly the right spot.
Yeah. I mean, it just confirms why those oversized holes in the base plates are so important.
Absolutely.
Because in the real world, you're not always going to get those anchor bolts in perfectly.
And you got to have a way to connect the steel to the concrete, even if things are a little off.
Exactly.
Yeah.
Okay, so to sum up our deep dive today, we learned that there are standard hole sizes for connecting steel to steel. And those give you a little bit of room for error during assembly.
Right.
Then there are oversized and slotted holes, which give you even more flexibility.
But they come with rules.
Right. You got to have an engineer okay them because they change how the loads are transferred.
Exactly.
And finally, when you're connecting steel to concrete with anchor bolts.
Yeah.
The hole sizes get a lot bigger.
They do.
To allow for the fact that anchor bolts are harder to place accurately in concrete.
Right. It's a whole different ballgame.
It is.
Yeah.
So what's really interesting to me is that these standards They're not just theoretical numbers.
Yeah.
They're based on what actually happens on construction sites.
Yeah, they take into account the materials, the environment,
Yeah.
and how accurately people can actually work.
Right. So it's like a combination of engineering and real-world experience.
Exactly. It's the science meeting the art of construction.
I like that. So whether you're getting ready for a meeting
Yeah.
or just trying to understand how buildings and bridges work,
Or just curious about the world around you.
knowing about these little details about holes and slots,
Yeah.
it actually gives you a much better understanding of structural engineering
It does.
and how things are put together.
Yeah, it's a whole hidden world.
It is.
Yeah.
And so I'll leave you with this thought.
Okay.
Think about how these tiny differences in size,
Mhm.
like fractions of an inch,
Yeah.
and the shapes of these slots,
Right.
how do they affect how efficient construction projects are,
Okay.
how safe and strong the structures are,
Uh-huh.
and how much they cost to build?
Yeah, that's a great question.
And then think about how engineers are constantly trying to balance the need for standardized designs with the
Yeah.
fact that things don't always go perfectly on a construction site.
Yeah, it's a balancing act
It is.
between the ideal and the real world.
Exactly.
Yeah.
Well, this has been great. Thanks for joining me on this deep dive
My pleasure.
into the world of holes and slots.
Always happy to talk about holes.
All right. Until next time.